In this video, we're going to learn how to factor a polynomial expression. So let's start off with this expression. We want to factor the following expression, 4x plus 2x squared. Now, the way we start off factoring an expression is we find the greatest common factor of all of the terms of the expression. And remember, the greatest common factor is just the largest expression that divides all of the terms. We can compute the greatest common factor by computing it for the coefficients and the variable separately. So first, looking at 4 and 2, the coefficients, what is the greatest common factor of 4 and 2? Well, that's just the largest number that divides both 4 and 2, which is, of course, 2. So there's a 2 in our greatest common factor. And now how about the variable parts of the terms? We've got an x and an x squared. What is the largest power of x that divides both x and x squared? Well, that would be just x. That's all that can fit into x, and that goes into x squared. So there we go, it's x. So the greatest common factor of both of these terms is equal to 2x. Now what we're going to do is we're going to write each term as a multiple of the greatest common factor. So we'll write 2x times something plus another 2x times something. Now this first 2x times something, that has to be equal to 4x. So 2x times what makes 4x? Well, 2 times 2 makes 4, so we need a 2 in there. And then x, that's already included in the 4x. So all we need is 2. 2x times 2 makes 4x. Okay, that's good. Now let's do a similar thing for 2x times what makes 2x squared. Well, we've already got the 2 there, so we don't have to worry about that. But we need to get that x to an x squared. So x times what makes x squared? Well, x times x makes x squared. So now we can go ahead and factor out that greatest common factor, 2x. It's multiplying each of these terms. So we can undistribute and keep the leftovers in parentheses. The leftovers are just 2 plus x. So there's the factored form of the expression, and you can double check that it's equal to the original expression. If we distribute, 2x times 2 makes 4x, and 2x times x makes 2x squared. So there we go. We're done. Alright, next question. Now this is pretty similar to the previous question. In order to factor this expression, we need to start off by finding the greatest common factor. So what is the greatest common factor of 7ab and 21b squared c? Well, let's start by looking at the coefficients, 7 and 21. What is the greatest common factor of 7 and 21? Well, that's just 7, because 7 is the maximum number that divides 7, and it also divides 21. But we're not done yet. We also have to look at each of the variables. There's an a in 7ab, but there isn't an a in 21b squared c. So the greatest common factor should not include an a, because there is no a in 21b squared c. Alright, moving on to the next variable, b. There's a single b in 7ab, and then there's a b squared in 21b squared c. Now what is the highest power of b that divides both b and b squared? Well, it's just b to the first, or just b. In other words, 7ab contains a single b, 21b squared c contains 2 copies of b multiplied together, so the highest number of b's contained in each term is just a single b, so just a single b. The last variable, of course, is c here. There's a single c in 21b squared c, but there's no c in 7ab. So we don't want to include that in the greatest common factor, because c doesn't even appear in 7ab. Alright, so greatest common factor is 7b, and now we want to pull that out of each of the terms. So we want to write each term as a multiple of that greatest common factor. So 7b times something plus 7b times something. Now we just need to fill in the somethings. Okay, first off, with the something on the left, 7b times what makes 7ab? Well, 7, we've already got the 7 here. An a, oh, we don't have an a yet, so we need to include an a. And then a b, we've already got the b here. So 7b times a makes 7ab. Yeah, that's right. Okay, now 7b times what makes 21b squared c? First of all, 7 times what makes 21? Well, that's just 3. And then b times what makes b squared? Well, we just need another b. B times b makes b squared. And then we also need a c. That appears in 21bc, but not in 7b, so put a c at the end. So 7b times 3bc makes 21b squared c. Now here's the final factoring step. Remember, we just pull out that greatest common factor, we undistribute it, and the leftovers are just a plus 3bc. We can double check ourselves. 7b times a makes 7ab, yeah, and 7b times 3bc makes 21b squared c. Yeah, so if we were to distribute this, we'd get an expression that's equivalent to the original. So this is indeed our factored form. Alright, so now we want to factor the expression 9u squared v minus 3u squared v squared plus 18u cubed v. And again, as usual, we start by finding the greatest common factor. So first we look at the coefficients, 9, -3, and 18. And let's just focus on the number part. Don't worry about the negative, just look at 9, 3, and 18. What's the biggest number that divides 9, 3, and 18? Well, you might notice that these are all multiples of 3. 3 times 3 is 9, 3 times 1 is 3, of course, and then 3 times 6 is 18. And we can't go higher than 3 because 3 is the biggest number that goes into 3. So greatest common factor will contain a 3. Okay, now let's look at the u variable. We've got a u squared, and a u cubed. So what's the highest power of u that goes into u squared, and u cubed? Well, it's just u squared. U squared is the biggest factor of u squared, and it also goes into u cubed. So 3u squared, and then how about v? Well, look at the variables v, v squared, and v. What's the highest power of v that goes into all of these variables, v, v squared, and v? Well, it's not v squared because v squared doesn't go into v, so it has to be just v. So greatest common factor is 3u squared v, and we can pull that out from each term. 3u squared v times something, and then we'll keep that minus sign, so minus 3u squared v times something, and then plus another 3u squared v times something. One of these for each terms. Okay, so first term, 3u squared v times what makes 9u squared v? Well, 3 times what makes 9? 3 times 3 makes 9. And then u squared, we've already got our u squared, v, we've already got our v, so it's just 3. Next up, 3u squared v times what makes 3u squared v squared? Well, we've already got our 3, we've already got u squared, we need v squared, and we only have v. So what do we multiply v by to get to v squared? It's just v. And then lastly, 3u squared v times what makes 18u cubed v? First of all, 3 times what makes 18? Well, that's just 6. And then u squared times what makes u cubed? Well, that's just u. And then v, we've already got our v here. Now we go ahead and undistribute that greatest common factor, 3u squared v, and it's multiplying the leftovers in parentheses, 3 minus v plus 6u. Pay special attention to that minus sign. We have to keep the same addition or subtraction symbols when we undistribute. So there we go. There is the factored form of our expression. 3u squared v times, in parentheses, 3 minus v plus 6u. So now we know how to factor a polynomial expression, and in the future we'll get a lot of practice with factoring, because it turns out to be very useful in solving nonlinear algebraic equations.